Hello, I'm Philip Stoughton at SMTAi. I'm joined by Ranjan from Cimetrix. Cimetrix.
Yeah.
Thanks for joining me. You've been doing some work you've been in the semiconductor industry for a while and doing some work there, but also bringing some standards from that industry to this industry.
Right.
Tell me a bit about how that's working and what the adoption's like.
So that in semiconductor industry, the wafer fabs are about like $9 billion. They're the most sophisticated factories in the world. So they had actually invested in a lot of automation communication protocols over the last 15 years and has been adopted by the standard. So everybody from Intel, Samsung, Motorola, they all use that standard. It's called SXGEM, and they have been using it for a while. So it has actually been adopted in the PCB industry. So the TPCA, Taiwan Printed Circuit Board Association, has adopted this as their standard. So they went and looked at all the different standards. So instead of developing a new one, they adopted the one that is being used in the most sophisticated parts of the factories in the world. And then it has also been used in SMT. So if you look at Fuji, MPM, Panasonic, they all support the SXGEM standard. So you can actually buy an SMT line today that has all the same communication protocols.
And in terms of the way that fits with the other standards, we've been talking today about the Hermes standard, the CFX standard, OML standard. There's so much out there. Where does this sit within those? Is it at the machine-to-machine level? Is it the thread of data going through the machines, or is it the data that's coming up to the MES system?
It's the data that comes out to the host.
Okay.
So it can work from machine to machine, but its primarily use is from machine to host. And it's two-way, and it is model driven. So it assumes the machine will have a finite state diagram, and when it changes states, it sends messages, and you can control the machine. So it is meant for a completely automated factory.
Okay, which is what they're doing in the semiconductor industry.
Right.
And you believe that the SMT industry can learn from that, and it's a standard that can be adopted really quickly.
It has been used before. So like Motorola was using it 15 years back. All our factories were actually using this protocol, because the companies that had been vertically integrated, like Intel, every machine in Intel uses SXGEM. So that's how they buy it. So a lot of companies actually do use it now for all their machines.
Okay. And when we look at what's going on right now with Industry 4.0, Smart Factory, artificial intelligence, augmented reality, digital twin, all these different elements coming together, is that a standard that can meet the demands of all that data, not just data transmission, but data utilization?
Absolutely, because it has stood the test of time. Like again, back to the most sophisticated and most expensive factories in the world have been using it for almost 15 years continuously. Even today, every machine that goes into a wafer fab has to have a SXGEM interface. And that's how they control the machine. So for Factory 4.0, one of the primary things is connectivity, right? If you don't connect the machine, you don't have the data, you really don't have anything that you can use, right? So in this particular case, you do have the data, and the way it is model driven, it actually enables you to get data as you want. So it is not like drinking from a fire hydrant, like you're choking. This is actually what you want, when you want, and how you want. So it has stood the test of time, and that's what all the big data that is being done in the wafer fabs, where they look at like impurities on a wafer, that's all being done by these interfaces.
Yeah, and I think that's really important, and I think we need to look outside of our industry sometimes and learn from other industries that have been basically running almost Industry 4.0 for some considerable time.
Yeah, and they also had the investment. If you think of a $8 billion, $9 billion fab, their SIM budget is anywhere from $70 to $200 million. So they have had the wherewithal and the resources to invest and debug this. Whereas if you look at an SMT line, I don't know, maybe anywhere from $5 to $10 million. Their SIM budget is in the 200K range. So the investment is so massive that they have debugged all these things, whereas the other industries don't have that. And if you look at the PCB industry, that's even lower investment, so they can easily reuse it, which is what the Taiwan TPCA guys, KPCA and JPCA, they're all doing that.
Yeah, fantastic. Well, thanks for sharing the insight with us, and a pleasure to talk to you. Thank you.
Thank you.